Greetings, I'm Professor K, and in our last video we got a high-level overview of all the features that we need to be familiar with up inside of Ghidra. Now that was just a 35,000 foot flyover. There is much more underneath the hood of Ghidra, but for what we're doing, this is going to provide us with a good foundation. So with that being said, we're going to move on with using Ghidra to perform a reverse engineering of the crackme0x00.exe file. A crackme is a small program designed to test a programmer's reverse engineering skills. They are programmed by other reversers as a legal way to crack software, since no intellectual property is being infringed upon. The crackme0x00.exe is a simple program that just needs a password to open. Our file could be any executable that requires a password to open. For this demonstration, I will be using one installation of VirtualBox with the extension pack, one virtual install of the latest version of CSI Linux, one virtual install of Windows 7 Enterprise, and all my VirtualBox network adapters are set to NAT network. I will place a link for the crackme0x00.exe file up inside of the description for this video. I have downloaded a copy of crackme0x00.exe onto a virtual install of Windows 7. I've copied the path into the command prompt, and we're now ready to go ahead and launch this executable to see what it actually does. And the first thing it wants is a password before it'll open. Okay, so I don't know the password. So I'll just type in 1, 2, 3, 4, hit enter, comes back and it says invalid password. So our task is to reverse engineer this program so that we can find the password. Now one trick that we can use to help us find the password is to use a defined string. Now our defined string that we're going to use is password : that is our preferred or our defined string that we're going to search for up inside of the program. Back on over on my CSI Linux desktop, I have Ghidra up and I have the project with the crackme0x00.exe file ready to analyze. Let's go ahead and double click it. And it's going to ask me, do I want to perform an analysis? I'll say yes. From here we're going to go ahead and load our default scanner that we need, which is the Windows PE86. Now while we're in here, if we want, we can go on back up in here and we can get rid of one of those scanners that gives us a little bit of grief. That is the PDP Universal. This one here is not going to be able to find what it's looking for up inside of the program, and it's going to give us an error. But we can prevent that error just by saying we don't need this particular scanner. Let's go ahead and analyze. So we know that the program has a defined string of password : so we're going to go up here to the window and we're going to scroll on down here and we're going to find the window that's going to allow us to look at defined strings. I'm going to go ahead and add this window to our view. Now over here, go ahead and make this a little bit bigger. Over here to the right we see all the defined strings that are part of the program. And here we see the defined string that we're actually looking for. Over in the listing pane, we see that the location that it references is also the same as being shown for the defined string password : Let's right click on this and we're going to select from the context menu, References, Show References to Address. We can go ahead and close this window. Let's go ahead and move back on over just a little bit to the right so we can see what's going on inside of the listing pane. Over in the listing pane, notice that after the reference to password : there is a call to scanf, that is a function, to receive the user input and then to make a call to the strcmp. We see that the user input gets stored in EAX and placed in a local variable called local_40. The string 250382 is also stored into a local variable called local underscore 3C. From here, both are passed on over to the strcmp function for comparison. The result of this comparison is checked against the value 0. And if it is equal to 0, then the text password OK is printed. Otherwise, it takes the jump and it prints the text invalid password. So back on over on our crackme application over on our Windows 7 virtual machine, I'm going to go ahead and I'm going to launch it one more time. And this time I'm going to type in the password 250382. I'll hit enter. And it comes back and it tells me this time the password is OK. So in this short video, we saw that by examining the output of the program when we attempted to run it, we were able to capture a predefined string. We were then able to search the program for that predefined string, and that led us to the password 250382. And so that's going to conclude our short video presentation on how we go about performing a reverse engineering of a simple executable up inside of Ghidra. You got questions, you got concerns, please don't hesitate to reach out, contact your instructor, and I'll see you in my next video.